Hello, everyone. Good morning or good afternoon, depending where you are in the world. Welcome to this Telit and Cradlepoint webinar, Hybrid Private and Public Cellular and Wi-Fi Networks, What They Are and How They Work. I'm Amanda Flink, the Head of Global Events here at Telit, and I will be moderating today's event. Before we start, we'd like to understand what best describes your interest in private LTE and private 5G. So please, audience, if you could take a second to fill out the poll question, which you'll see on your screen now. Now let's get to know our speakers. To explain this topic today, I'm pleased to be joined by James Weber, the Director of Product Marketing at Cradlepoint, and also Safi Khan, the Regional Product Marketing Director at Telit. Just before I hand it over to Safi to start the presentation, I have a few quick reminders for our audience. I would like to encourage you all to interact by posting questions. We will have time to answer some of those at the end of the presentation today. Simply submit a question by posting in the box to the right of the slides. Also, be sure to check out the resources section in the upper right-hand corner of your screen for some additional information on today's topic. And finally, we will send out a replay link to all attendees at the conclusion of the webinar today. And with that, Safi, I will hand it over to you.
Thank you very much, Amanda. Good afternoon and good morning, everyone. Very nice to have you join us today to talk about hybrid private and public cellular networks and Wi-Fi networks. So today we will be talking about quite a few topics which cover a range of networks, ranging from public cellular networks all the way to private cellular networks, as well as Wi-Fi. So let's just start by explaining or defining some of these terms so that we can set the proper context for those of you who may be understanding these terms in a different way. So when we talk about a public network, we are really talking about a cellular network or a carrier such as Verizon, AT&T, T-Mobile, where you have a wide coverage nationwide, and that's depicted here on the right side of the diagram. So this is essentially what you have in your smartphone or tablet or any device which is mobile with you, and you have coverage, pretty much outdoor coverage as well as some indoor coverage nationwide. And then on the other end of the spectrum is a private wireless network, which could be a cellular network or it could be a Wi-Fi network. And by this, what we mean is that it is using cellular technology, but it is not a nationwide network like the one that I mentioned before. It is operated by an entity such as could be a Verizon or an AT&T or T-Mobile. However, it could also be a private company, which is basically operating a network for its own assets, such as properties like a hospital or a campus or a manufacturing facility or a school. And what the idea is that you have a private network where only your authorized users come onto that network, and those devices are inherently under the control of your policies, and you only allow the data to leave your premises if you want it to. Otherwise, it stays local to your area. And then it could also be built with Wi-Fi. And then what we are going to talk about today is that you can also then have a private Wi-Fi network or a public Wi-Fi network, and how, when you combine these, is what we would call a hybrid network. So basically, that's essentially shown here in the next slide. And let's talk about how this can be visualized. And, we will be using some of that terminology that I mentioned in the beginning, but we will also be mixing in some of the new terminology, like PCN is what we will call a private cellular network. And that is going to be more of our focus today, to more look at the private side of these networks, and especially cellular versus Wi-Fi. Okay, so So basically, you can have three ways of having these networks, as I said earlier, but this is basically breaking it down into the pieces of the network. So in the network, there is always the core network, which is basically your servers that are implementing all of the routing and the switching and the priority and the quality of service and things like that, authentication, security. So the blue cloud, the premium core, and the data routing and the public core, these are basically showing the makeup of the network. And then the tower is the physical radio, or what we call the RAN, which is radio access network. And so that's basically sending the beams, the radio beams that basically connect the wireless devices to each other. So if you look at a dedicated private cellular network on the left side, you have the campus, and it's being lit up by a tower, like the blue tower. And the public network is not in the picture because we're only looking at a dedicated private cellular network. So you can assure quality of service. Like I said earlier, your data stays on the campus and you control it 100%. You can do interworking with a public network, which is the yellow. So let's move to the middle one. Now what you're doing is that your devices are seeing the private radio waves, but they're also seeing a public network, such as a Verizon, AT&T, T-Mobile. And then these devices have dual SIM technology, for example, and they could activate one SIM for the private network and another SIM for the public network. And when you are within the private network coverage area, you stay on the private network. And let's say you move away and drive away from campus, then your device will connect to the public network. And then there's another way, the third one, which is a virtual private cellular network. And what happens in this case is that the entity, such as a Verizon or AT&T, T-Mobile, decides to make a slice of their network become a private network for enterprise customers, for example. And from the same tower, which is sending you the public signals, they also send you the dedicated private signals. And so your service is from the same carrier, but you see it as a virtual private slice of the public network, and it comes with all of the benefits of the private network. And next slide, basically, since today you know that 4G and LTE has been around for a long time, and it has good benefits for private networking. However, right on the horizon now is private 5G, and that is also a big hot topic of discussion for some of the key verticals where low latency and high efficiency of 5G and high performance comes into play. So why private 5G networks, especially for an enterprise? You can see some of the benefits listed here on the right, and some of you may be familiar with these, but just briefly, excuse me. So 5G technology, which is new radio for industrial IoT, comes with many benefits, such as lower latency. So there's actually special hooks in the technology to give under 1 millisecond latency end-to-end, coming in release 16 of 5G, so it's not too far away. So that's very useful for applications such as robots and high-precision machine-to-machine communications, and AR and VR experiences in medical field, or drones, autonomous vehicles, lots of applications where very low latency is very useful. And then higher reliability comes with it, where you're guaranteed that the transmission will take place. The performance is higher, you have much higher data rates in 5G. And then the way you use the spectrum is also flexible and optional. And then you have this concept of edge computing, of course, so that brings the network to the edge, so that more and more devices are intelligent at the edge, and they can do a lot of the processing without burdening the cloud. So 5G in a private setting is very useful for like the verticals I said, and manufacturing, industrial and enterprise, and so on. So with this, I've set up the stage where we've kind of defined what the private cellular networks and public cellular networks are, and then of course Wi-Fi networks are. So I will now hand it back to James to talk about, what does it take to actually implement things like these from a real product perspective. So go ahead, James.
Yeah, thanks, Shafi. Hey, it's great to be with everyone today. And I thought I'd just put at least one little slide up to give you a little bit of an idea of who Cradlepoint is. And you can see from the slide that we get involved in a lot of really big deals, companies with lots of different sites and into the tens of thousands of sites, and generally recognized as the worldwide leader in connecting vehicles, places, and things to LTE and 5G cellular networks. So by places, I mean fixed wireless access, and by things, I mean IoT. So that's our background, and what we're seeing is a lot of interest in private cellular networks. I think some of it's driven because 5G is moving rapidly into the landscape, and people are being very are recognizing the benefits, and sometimes they want to go a little faster, maybe than some of the rollouts, and sometimes they want to have a little more control. And so I think between these two reasons, we're seeing a lot of interest. So what I'd like to do is just walk you through maybe some conceptually what you would look at, your kind of decision criteria, and maybe help you as you kind of discover this journey of what a private cellular network might do for you. So if you look at this diagram on the left, this is a very big warehouse, and this is very, very common now, where entities are coming to us and telling people like this and saying, hey, what if I want to put a network here? What if I want to connect hundreds of devices here, from video cameras to self-help kiosks, all kinds of things? What am I looking at? Well, from a coverage perspective, these are large areas. There's penetration issues. There's oftentimes contention with other networks, and control becomes a really big thing. And so they stop and say, all right, well, what are my options? And so there's a public cellular option. In some cases that works. You do have this kind of per bit pricing. Sometimes, depending on the plans, that may be prohibitive. It may not be in a coverage area. There may be bandwidth contention and so forth. So in many cases, public cellular is such a good option, but may not be when you start thinking about what you see on the left-hand side. And then you consider Wi-Fi, and you think, well, all right, Wi-Fi, we know it well, we're comfortable with it, but have we really implemented it in this large of an area with this kind of obstacles and congestion and so forth? And Sophie is going to go through some reasons why Wi-Fi may not work very well in these areas. And so when those two options are kind of ruled out, it really comes to a decision around private cellular networks. And so as you look here, you can see the attributes that kind of uniquely ascribe to private cellular networks. So if we talked about the low latency and the scalability and security, but it also has this ability to really control well. And so the way that you really ought to look at a private cellular network is it's really a public cellular network, but turned private. So it has the same kind of quality and performance that you would expect from a large carrier, but that it also is private and allows you to have the kind of control and do some kind of the tweaking that we talked about. So if you look at this, maybe a little bit of a summary slide here, you can see that, okay, so who generally would be looking at these kinds of things? And the answer is, I've answered some of it already, though. It's organizations that are familiar with the benefits of wireless, and they understand that there are just a lot of situations where wired just won't work. But the Wi-Fi and public cellular networks may not be the best option for them. Who operates it? Well, certainly an organization can operate it start to finish, but you can also have an arrangement with a mobile operator where they can either deploy and you operate, or they can deploy and operate it as well as a managed service. And so those are really nice options. You get a lot of flexibility. And then just to think, what kind of spectrum does it use? So This is a really nice area where global entities, governments are starting to say, okay, we realize the value here, and so they start to free up this space, particularly in the U.S., for this kind of thing. So there's unlicensed spectrum that both enterprises and carriers can use. There's licensed spectrum, where generally speaking, a carrier would own that license and you would lease from a carrier, although there are companies that buy their own licenses in certain areas. And then there's a shared model where different entities can work within the spectrum. And the nice thing about public cellular networking is that within the infrastructure, it has the intelligence to handle that sharing. And a good example is in the U.S., this kind of CBRS spectrum that the government will allow for use, except when there is it's by some ports for Navy and so forth, and they have the ability to manage that shared spectrum in those kinds of situations. So again, that's kind of the overview of why you would consider and what it would look like. I'm going to turn it back to Safi to get into some details about, really more details about why you would consider PCN against some of these options we've talked about.
Okay, James, thank you for that intro. Great stuff. So let me get into this new concept of the hybrid networks that we have been trying to explain to you. So what I'm showing here is 3 tiers of service. So we thought that it would be great to highlight a hybrid network by use of an example of an airport. Now, we have all been to an airport, and it's a very easy example to follow. And what happens is, as you are driving to the airport, your phone is connected to a public 4G or 5G network. You're getting gigabit speeds, and you have voice services, and you drive closer and closer to the airport, and then you finally get into the terminal. Now, inside the terminals, the cellular coverage may not be as good. So you may have spotty coverage in the terminal. So some of the airports offer, for example, free public Wi-Fi. Now, of course, they are paying for it, but to the consumer, it's free. So that's the next tier of service, where it's basically a Wi-Fi service for you to connect, check in, check your flight status, etc. So you have this public Wi-Fi network, and it may not be the best quality, but it is giving you connectivity when you need it. And then another layer that you may not see but is there is actually a private Wi-Fi enterprise-grade network that may be present, or a private 4G and 5G network, which are also now popping up. And this is not visible to the consumers, but it's really for the airport operations, the logistics, and mission-critical systems, such as the connectivity between the ground airport operations and the aeroplanes that come in and out of the terminal gate. And so this has to be very high reliability. It has to have strong connectivity and sustainable good data rates. And of course, number one, it has to be a secure network. So because you're dealing with mission-critical systems here. So essentially what you have at an airport is a hybrid network. And depending on the need and depending on the use case, you're using a combination of LTE, 4G, 5G, and Wi-Fi technologies. Now, Wi-Fi has evolved significantly, and the new latest standard of Wi-Fi is called 6E, which is the 6th generation Wi-Fi, and E is for extended spectrum range, which is the 6 gigahertz band. And now Wi-Fi networks are evolving quickly to also bring high reliability and scalability and security, all the concepts of cellular technology. So the Wi-Fi 6E that will come out, it's already there, but it's in its early stages, will also try to bring strong security and reliability to the networks. So with this in the background, let's take a look at some of the data that we have in which we actually get an idea of the differences of these technologies. So now, continuing with the airport airplane proof of concept, that was some data provided by Lufthansa for their operations. You can see in these two graphs, let's look at the one on the left. So there's a ping latency, which is basically how long it takes to reach a server or an endpoint and back, end-to-end latency. And so as you can see here, the line graph is the average latency, and then the bars are the maximum latency. So in this case, the Wi-Fi does not really offer low latency in terms of usage. And that's mainly because, first of all, this was Wi-Fi 5, not Wi-Fi 6 or 6E, which will bring the latency down. However, even on the average, it's 72 milliseconds. And then public 4G network offers 35 milliseconds. And then 5G private network gets the best performance in terms of 16 milliseconds end-to-end latency. And that's inherently because 5G is a new radio. The core network is much more efficient, as well as the physical layer has more efficiencies. And so that's why you're able to get a very low latency number. And then moving over to the right side, you also look at the average download speed. Now, this is the speed of connectivity between an airport terminal or operations and the airplane, which is parked at the gate. And they need this for maintenance and things like that. And they measure it outside the airplane and also inside the airplane. So here, as you can see, the data speed for Wi-Fi is in the range of 20 to 29 megabits per second, depending on outside or inside the plane. And then public 4G is a little bit higher, 128 versus 116 megabits per second. And then the private 5G network was able to get much higher data speed of about almost a gigabit per second outside the plane, and then pretty decent speed inside the plane. So essentially what you see is in a private setting, cellular can perform better, especially with outdoor-indoor coverage when it is involved. And basically it has higher level of security. We've all seen the cases of Wi-Fi getting hacked by hackers, and the SIM authentication of cellular makes it, authorized users only to come onto the network and so on. So in that sense, this gives you a picture with some data on what you can expect. Now, on the other hand, Wi-Fi is a lower cost alternative in terms of total cost of ownership. And that's a whole different area where we don't have time today, but that's another good area to compare the cost of operating these networks. Now, one more detail in terms of that latency that I talked about is this graph, and of course this is a little too technical maybe to cover in detail, but just let's cover the very high-level highlights. So again, these graphs are colored. The blue is public LTE, and then the dotted blue is a private LTE, single user. Then the green is a private LTE, and a dotted green is a private LTE loaded with many, many users. And then the same thing with red is Wi-Fi 5 or 6 with single user, and the dotted one is Wi-Fi 5 when it's loaded. So what you see here is on the x-axis is again the latency, which is end-to-end delay in a network. And on the y-axis is the probability of getting the latency below that value. So as you can see, the Wi-Fi with the red has very good low latency as long as the number of users on Wi-Fi is not getting too high. When you start adding users, the latency gets out of control in terms of trying to achieve the 4 nines. 4 nines means 99.99%. Now, in the case of an enterprise or a private setting, you do want very high reliability and you want consistency. So with Wi-Fi, the consistency is not achievable in terms of reliability, but in terms of private cellular, as you can see, it's much better than Wi-Fi. And then when you add mobility, so the one on the left was for fixed, and then when you add mobility, for example, when you're moving around, it gets even worse, to about 4 seconds to achieve the 4.9 latency for Wi-Fi. But it's still under 150 milliseconds for private LTE. So these two graphs give a good kind of idea on the data between cellular, Wi-Fi, public versus private. So let's continue talking about basically the deployment scenarios. And we kind of touched on it earlier in one of the slides, but it's the benefit of a private network is that it's actually physically isolated. So again, it's more secure by design. You put up the towers or the small cells that do the transmission. You control the server. It could be on premises or it could be in your secure data center. And you control all of the SIM authentication and who gets to be on that network. And so that's one scenario. Now, you could also have a shared 5G network. And then now, like I said, if with 5G, the whole network itself has been redesigned. So it has more components which are modular. They can be shared between the public and private networks, so the workloads can be virtualized in a cloud or a server instead of having dedicated hardware and things like that. So then let's talk about a few of these really important use cases, and I'll give it back to James to cover that.
Thanks, Safi. Yeah, so we have a lot of interest and a lot of organizations, very large organizations, coming to us and partners. So I'll show you a slide in a second that shows the whole ecosystem around a private cellular networking environment. And so these are the most common that we've seen from our partners and ourselves, of, again, those coming to us. And you have some illustrations here with education, smart cities, transportation, manufacturing, natural resources. So I'm just going to touch on these lightly. I'm not going to go into a lot of detail, but just give you a little bit of a flavor of what some of these look like. So a little bit surprising is education. And let me just give you an example. There's a school district in Utah called Murray School District, and they were looking at their own private network, but a really interesting problem cropped up where they have some students who they call underconnected. These are students that live nearby the schools, but they just don't have the kind of connectivity that will allow them to do the kind of homework that they need to do at nights. And COVID really exacerbated that problem, because now you have several people, including working professionals in the home competing for bandwidth. And so what they did is they implemented a private cellular network, and they beamed the signal across streets and parks to hit residential housing. They used some heat mapping technology from us, and they used some mapping data that they had from to tell which students were a little more low income than others. And they then turned their antennas to those sites. And they were able to provide these homes with their own private connection to the school network. And so they used Cradlepoint endpoints in their home, these little routers in their home that connected to the small cells on schools as well as churches in the area to allow them to get that kind of coverage. And so that was just a great story. But you can see the application here when you go even beyond K through 12. You start thinking about universities and so forth. There's a lot of times where having this kind of industrial strength private network would make a lot of sense for these organizations. Now, smart cities, it is almost unlimited, the number of things that you can connect. And here are just a few, from digital signs to smart chargers to traffic lights and so forth. And we have customers who are doing this kind of monitoring where they have video-enabled AI, or AI-enabled video, where they can, through machine learning, project certain situations and intersections in public areas and make decisions with traffic lights and other things and send alerts and so forth. And so this certainly is a safety kind of approach for a lot of cities, but there's also an efficiency approach. And so cities are really looking at how do I get the kind of smartness that I want in my city that make it as easy as possible. And certainly running wires everywhere is not the answer. Transportation is burgeoning as well. Any kind of port, any kind of distribution center, we'll talk about a warehouse in a second, are just prime candidates here. And, it's really anything from telemetry on cranes to telemetry in vehicles that go around the port sites, nearshore vehicles, all of these, nearshore vessels, all of these would really benefit from having the connectivity that would give them the efficiency that these ports are looking for. Talked about this warehousing, and so we have some very large companies coming and saying, hey, I have these massive distribution centers. I need video in hundreds of places. I need kiosks, and I also want to power my offices. And I want to do it through one network. And private cellular networking is just really a great option for them. Certainly they're starting today with private LTE. They're looking tomorrow with private 5G. It just gives them the kind of coverage that that allows them to focus a lot more on the logistics part of it as opposed to the business. Natural resources are another big opportunity. This is anywhere from mines to oil wells to any kind of drilling sites. We have an interesting situation with a customer in Canada that's doing mining, and they're enabling these massive dump trucks they have that weigh just tons and tons with these massive tires. And if those things go down, it costs them hundreds of thousands of dollars. And so they have monitoring systems on them. They're tracking them. They're having them take the most efficient routes. And that's all done with the private cellular network. And you can imagine, you start going into the mines themselves, that's the only option is the kind of network that we're talking about. And then I want to just give you just a couple of case studies. So we talked about use cases. This is case studies. I gave you the example of the Murray School District. Here's some examples of partners that we've used as well, and I'll give you a little bit more of an example of the ecosystem. The American Dream Mall. Hopefully, if you've had a chance to go there, that's fantastic. It is this massive kind of entertainment and shopping and retail complex. One of the problems that they had is they were so aggressive in getting the building done, they really didn't think ahead to the parking to make it as modern as the building, and so they wanted to put these dynamic parking signs in, digital signs that say, hey, there's X amount of parking spaces over here, and be very directive to those who are parking. And they had already laid the pavement down, and dragging wires to those areas has been super expensive, and so they used wireless and they used the private cellular network to be able to make that happen. Take servicing company, imagine they're coming in and serving these massive industrial tanks. A lot of what they do involves technology. It's kind of their only option. So in this case, the private cellular network is portable. Had a customer that runs a very large transit system, and I think they put in around 500 kiosks with cameras around the kiosk at those areas, and that was all done with private cellular networking, again for the reasons that we spoke about. So here's what a little bit of an environment looks like. This is important to know. There isn't just one system that you implement in a private cellular network, and generally speaking, it's not one company. Usually there's some partnerships. Now, I will say that the technology is so mature that these interlock really, really well. And so there are lots of interlock between all kinds of vendors. But this is generally what it looks like. So outside of the private cellular network, you will have these cloud management elements that manage the SIMs and the small cells. You also have this SAS manager, and this is a US kind of thing, and this is what manages that CBRS spectrum, the sharing we're talking about. Then also on the right-hand side is the Cradlepoint cloud management of the endpoints themselves. So that's all the cloud piece. And then everything in that gold circle is the private cellular network. So this is now completely private. So you'll have the evolved packet core. You know this term from the carriers. So again, the same quality of equipment there. And then you have the small cells. So small cells is equivalent to in Wi-Fi what we call access points, but these are small cellular towers. So now they can either be in a little tower or they can be mounted in different places. But these are, again, these industrial strength ability to get access to the network. And so you'll have direct connect. You'll have anything from a smartphone to a scanner to a kiosk, any of those things that are in there. So the key here is if it has a SIM card, it will connect. And then you'll have some devices that will not have SIM cards in them, or it wouldn't make sense to have SIM cards, or they're close in proximity. And that's where you'd use more of a gateway kind of approach. It's actually a router, and this is where Cradlepoint comes in. And Cradlepoint provides these routers, and what connects to those? Any kind of Ethernet-based IP camera. You've got any kind of office equipment that would connect via Wi-Fi, Bluetooth, or direct connect with an Ethernet cable. Sensors included. So this really becomes kind of this aggregator of all these things that don't have SIM cards, because the SIM card is actually in this router. So that's the structure. Now let me give you just a little bit of a flavor about the kind of I call them gateways and routers. They're interchangeably in the IoT world. It's usually called gateway. Every other place it's called routers. But each of these, let's call them gateways, have routing capability. So routing capability for the private network, and if you choose, public. So Safi talked about this ability to be hybrid. So all of these would do hybrid. So again, less of a product pitch, more of just to give you an understanding of how these work. So on the left-hand side, this first model is purpose-built for IoT. And so you can see all the things on the left-hand side, from kiosk to students in home. Then there's some mobile versions. So these will go in vehicles, smaller vehicles. There's a model, and there's larger vehicles for a model. And again, remember that within the private cellular network, it's working within that range, and then it goes public with very high security that comes with the public network, and they'll be able to hand off. So think of maybe a large university campus with buses, or a K through 12, the buses that move in and out of that private network. And then the two on the right are fixed wireless access for what we call branches. And so these would power small offices or classrooms, and then this E3000, the larger. Now what's missing is we've since introduced, since this chart was made, another mobile 5G product. So the great thing about this 5G product is it has a module that has both a Cat20 LTE modem and a 5G modem. So it gives you a lot of flexibility, and gives you the flexibility to use a private 5G and public 5G as well as LTE. So if you stand back and look at this gives you a lot of options as you look at a deployment that wouldn't be just standard fixed sites. There'll be lots of different ways that you'll be connecting endpoints, and it's nice to have that flexibility. And so I just want to introduce this last piece, which is this purpose-built endpoint that we just came out with. And again, the reason we came out with this endpoint is that there's demand. People are asking for it, and anywhere from all these use cases, people are saying, hey, we want some purpose-fit things. So I put these characteristics up here to give you a little bit of an idea of kind of where we're at. And so these everything that I showed you on the prior page can lock onto the CBRS bands, have this dual concurrent Wi-Fi, and again, that's probably one of the major ways that the connections occur to the gateway. Build it ruggedized, because in most environments that's going to be a requirement. So by ruggedized, this is one that will handle the dust, handle vibration, those kinds of things. Isn't submersible. That would be another kind of level of ruggedness. But these are very much meant to be on walls in warehouses, to be in trunks, and so forth like that. All right, and with that, I am going to turn it back to Amanda. I think we have maybe some questions that we might be able to answer.
Yep, thanks, James. Really great information, guys. Before we get to the audience questions, I am going to drop just one last poll here. If you'd like to have one of our experts contact you directly, please respond here on the poll and we will have someone reach out. As James said, we now have time for questions. We've gotten quite a few here, and there's still time to ask a question. So please feel free to submit using the box to the right of the slides, and we will do our best to cover it in the time we've got left here. So I'm going to just dive right in. First question I see, with CBRS and other private networks being installed now in some campuses, will it be possible that the same company switches to private 5G for the next wave of installations? Will you need all different devices for those two types of coverage?
Yeah, I can take that one. So, 4G and 5G are both cellular technologies. They are both defined by the same standards body. It's called 3GPP. However, like I've been saying, 5G is a new technology. It's a new radio. And so the 4G modem cannot operate a 5G signal. It cannot understand the signaling of the 5G signal. So if you have deployed a 4G network, you will have to upgrade it to new devices that have the 5G modem in it. So that basically brings in all of the benefits of 5G into the picture, and you only need to do that if you need like the low latency or the very, very high performance of 5G. So 4G is still here to stay for still a very long time, and it is the more prevalent, the lower cost solution, and still offers very good, very high performance. So I would say as a decision, what you have to look at is what is the reason that you want to upgrade to 5G, and if the reason is for that low latency or high performance, and if you can justify the cost, then yes, you will have to upgrade the equipment. And James, if you want to add anything, please go ahead.
Yeah, Safi, and let me just speak a little more detailed on the endpoint itself. So if you're looking at implementing a PCN network right now, what you may consider is in some of your smaller devices. Yeah, maybe you buy 4G today and replace it with 5G later. In some of your more bandwidth intensive applications, you may consider the last part that I talked about, that is 5G and 4G, and buying now so that when you do switch, it will take both. And again, those are a little more expensive than the 4G, so you'd want to again look at kind of bandwidth considerations, and again, heavy bandwidth, you may want to consider something that would prepare you for the future as well.
Great, thanks guys. Next question, is it possible for a networking device to also have a connection to the public network, and when would that make sense?
Yeah, I can take that one. So I think a really good example is in the education use case, where you may need to have, really want that strong private network around campus, let's say in your service vehicles or in buses and transportation. But those are mobile. So as they move out of the PCN network, then it can flip to the public side. Again, same security. You don't lose any kind of, not the same security, but as good a security as you go to the public network. And then you're able to kind of have that flexibility all the way in and be able to, really go as far as you'd like. So that would be a really good reason to look at that. The other situation is, in this Murray Schools example, sometimes things happen, and the school IT manager did want to put, or at least look at the idea of having public cellular backup. So if something happened, it would automatically flip to the public cellular's backup. So he'd structure his plans so that would really be kind of a failover plan, and allow that kind of failover to occur, and just get a little more confidence that they'll always have coverage.
Great, thanks, Jane. Next question we've got, which organizations and standards specify cellular to Wi-Fi communication conversion and handoff?
I can take that one. So, so as I think we talked about this when you hand off, basically 3GPP is the body. It's called Third Generation Partnership Project. So 3GPP defines very clearly the whole specification for how a cellular networking device, such as a user equipment, an endpoint, how is it supposed to authenticate to the cellular network and what protocols are used. And then within the same 3GPP, there is also the specification for other radio technologies such as Wi-Fi and how to authenticate with Wi-Fi. And there are some new technologies such as Hotspot 2.0 and cellular and Wi-Fi internetworking. So all of these are basically under the 3GPP umbrella.
Thanks, Safi. Next question I see, how do end devices like video cameras or manufacturing equipment connect to networking devices?
Yeah, I can take that one. So there's really three ways. Most popular is Wi-Fi. So each of the devices that I show have this ability to connect through Wi-Fi. Second is a direct connect, and that probably is a little more towards the video camera because it may be in its own little location and a direct connect that way. And then Bluetooth is another way. So not all of the devices that I showed you have Bluetooth. Some of them do. It really depends on, like the branches are built for more kind of a Bluetooth and some of the in-vehicle things. So those do, and that's kind of the three ways that you do it. And also, I just wanted to mention on one of the prior questions, just to give a little more explanation, the mechanics of how you go private and public is that within the router itself, you will have, in many cases, dual modems, and one modem would have the private SIM, and the other would have the public SIM. And then built within that router is SD-WAN capability that allows you through policy to determine when you switch between the two. And it could be based on conditions, let's say jitter or the quality of the call. That could be a reason to switch, or you could set up a geofence. So as soon as it hits a certain area, it automatically switches between the two. So hopefully that's helpful as well.
Thanks, James. Next question I've got, are prices for private 5G modules and devices likely to come down the new generation of 5G chipsets?
Yes, that's a good one. I can take that. Yes, so this is a really good question, and the answer is not just a simple yes or no. It really depends. If you look at the landscape of the chipsets that are available for 5G, we have the release 15 chipset out right now, and now people are talking about a new generation of chipsets for release 16. So I had touched on release 16 earlier. It has some new features that were defined by 3GPP again. And so what's happening is that there may be a fundamental shift happening in 5G where from release 16 onwards, there may be two tiers of chipsets available, where one becomes a very high-end premium chipset where all of the bells and whistles of release 16 are packed in there. For example, you can reach theoretically speeds of 10 gigabits per second. And so that could be something that goes into a high-end router from Cradlepoint, for example. At the same time, the need for lower-cost 5G has been recognized by the ecosystem. And in the same release 16, there is also the lower-cost chipset, which does still all of the good 5G release 16 features, but doesn't go all the way to the max, and thus it can save on the memory or the BOM, the RF front end, and the component cost and the chipset cost. So in terms of roadmap, you will be seeing in the future 5G modules which are even higher priced than the current generation, but you will also see lower priced modules which are targeting the value tier or use cases where all of the full speed of 5G is not required, but you do need all of the new technology of 5G. So we see the market being addressed by premium prices as well as the lower prices.
Thanks, Safi. And this is kind of to follow up on a 5G modules here. What about the private network band in EMEA, like with the Telus FN980 or an equivalent modem device with bands 40 to 3.5 gigahertz?
Yes, I can take that as well. Right. So the Telit 5G module is called the FN980. So this is a sub-6 5G module in an M.2 form factor. And then the FN980M is another similar M.2 form factor 5G card, data card with millimeter wave support. Both of these support band 42, which is the most typical band for private networking in EMEA. So that is supported by our module.
Great, thanks, Safi. Next question, what is the typical coverage range for a private LTE or 5G network or tower?
Safi, that's probably more yours. What do you think?
Amanda, can you repeat the question?
Sure. What is a typical coverage range for a private LTE or 5G network or tower?
Yes, this is a really good question. So basically, if you are familiar, there is an entity called OnGo Alliance in the U.S., and they are the alliance that is basically mandating or managing the private spectrum called CBRS, Citizen Band Radio Spectrum. So what happens is that the small cells that are allowed to be used for private networking are called basically CBS devices, CBSD. Now they come in basically two different classes. There is a Class A device and then a Class B device. So the range and coverage depends on what type of class you put in. Now the frequency of this spectrum is about 3.5 gigahertz. So this frequency is not the best in terms of propagation through many walls and long distances, such as the lower frequencies are. But again, it is a very good compromise because it's not in the high band. So it's still low enough that with the right transmit power, you can cover good size area. And the way to define, or the way it has been defined, is the maximum allowed power. So the Class B is basically higher power, and it's actually it's reverse. Class B is about 50 watts, which is actually 50 watts is a lot of power. It's about 47 dBm. So that basically, if you want to cover an outdoor area, is when you use a Class B device. And then for the indoor area where you don't need such high power, you use the Class A device, which is about 1 watt or 30 dBm. So depending on your terrain and depending on the type of material in your building, the range will really vary quite a bit. So it's really not easy to give you one number, but it really is better to define it in terms of how much power is allowed.
Great, thanks, Safi. And this question is somewhat related. How far can we expect a small cell signal to reach, like assuming CBRS?
Yes, like I said, it's the same as the previous question. So you would use the Class A CBRS device. If you have a basement or a garage, for example, it will be able to. You have to basically, when you deploy the network, you have to do this network planning, and that's where your small cells have to be placed there, and then you can do a field test to see how much of a signal are you reaching or you're receiving at the areas where people will need coverage. And if you want to go outdoors, then you go and upgrade to a Class B. Another thing you can do is you can install it at a certain height, like maybe let's say 6 or 10 meters above the ground, and that way it can reach further out.
Great, thanks. Next question I have, are all the ecosystems managed under one management system?
Yeah, I can take that because I touched a little bit about that in the in one of the charts. The answer is generally no, because each of those elements, really those three elements, all do very different things. However, you'll want to look at vendors, and in most cases, this is the situation where they will provide the interfaces are not crazy complicated. So, I know, for instance, when you're managing the endpoints, which is on the Cradlepoint side, it's cloud interface, point and click, wizard based, those kind of things. So it's really easy to be able to manage those. Doesn't take much at all. And we have customers with tens of thousands of devices managed by one person. So, in a PCN, it would be far less than that. And so that will not be a burden. But yeah, those three elements do have different management systems. So the Evolved Packet Core, and then the endpoints, and then those two external systems that kind of manage those. So those are separate.
Great, thanks, James. I believe that's all the time we have for today. I know we do have some questions that came in that we will not have time to get to live, but we will do our best to follow up with you all individually. Please be sure to check your inboxes in the coming days for the replay link of today's webinar. Safi, James, thank you so much for your time today, and thank you to all who joined us. Have a wonderful day.